Are we going?
Hold on. For some reason, it's putting a hat and glasses on you, and I didn't ask you.
Really?
Yeah.
Like the whole Snapchat thing?
Yeah.
Nice.
I have no idea why it's doing.
What do I look like? Well, I won't be able to see. Great. Great.
Alright. I don't know what's happening.
How do you shut it off? Welcome to a next. You want to go?
Go for it. You got a Heisenberg thing going on. I have no idea why.
Great. What if I just cover my face? Does it go away? Okay. Well, we're rolling on the other one. Welcome to our next Filabot live stream. We are going to be printing and talking about the considerations of printing with filled polymers. So filled polymers are plastics, filaments that have additives in them. Last live video, we talked about adding wood, metal, all sorts of different powders, stone, really anything that's not plastic, that's considered an additive that you're mixing in with the plastic. So Josh has been playing with making some of those, some wood polymer filled filament, which is what we have loaded right here. Very similar to a laywood material, or I guess that's the only one I know about. We still having a weird face on my face?
Yeah, and it's in black and white.
Okay.
I have no idea.
Alright, that's alright. So last week we were talking about how to make this filament. This is aluminum, 25% aluminum powder and 75% of that powdered PLA, which is, well, pulverized PLA, which is pretty much the same thing as powdered. It is ground up pellets to make smaller size so that matches your additives. This is the ABS one. We have a wood one, and we do have some other metals, but we didn't have enough to make it into filament, or we didn't try. We haven't had time. But that's some stuff we'll be playing with as well. The ratio that we found to work, we haven't nailed it down, is the 25% additive to 75% pulverized plastic. That probably would change with different additives because the plastic has to go around, grab the additives, and act as glue to hold together those additives. We'll be playing with that more to see how much additive we can add, like the max amount, and you'll have to step it down from there, past that max amount. So we have a very simple cube loaded into our Cura program. Very simple. What are we at in fill? Probably like 25%?
That's 30.
So we have 30% infill. We have 2 rings on the outside of the print. Again, very simple print. This is like what you do. This could be a calibration cube. Yeah. The printer has hopefully a 0.7 nozzle. Sweet. 0.75 nozzle, so that's the whole size on the nozzle. Normal printers, or the common size, is like a 0.4 millimeter or a 0.5, and those are what allow you to have a very fine print. The smaller the nozzle, the finer the print. Ooh, nice. Josh is spinning the print around. I like it. The larger the nozzle, the more rough or bigger the layers are on the printer, on the print that comes out. It's still in black and white?
It's not going to change.
Interesting. With additives in a plastic, you do want a larger nozzle. So that larger nozzle allows for the additives not to get bound up in a smaller nozzle and create, clogging, which we all hate. So we've never printed with this specific wood. This is the first spool we've ever made on our systems with that new PLA that we have. So we aren't sure if this is going to work. I hope it does. How's my sound on that camera? What?
There it goes.
Is it okay? The green bars, are they like in a good range? Okay. So just letting the printer warm up. going to start moving. A few things you want to keep in mind. There's two main styles of, not styles, but ways that companies go about building a 3D printer. One is an open source filament, which means you can take any filament and shove it in the hot end and extrude it out of the nozzle. The other side, or kind, or style, or build method is a closed filament system. So this is something that like MakerBot would do, or XYZ Printing, some other companies out there. Basically, they want you to use their filament, which can be limiting in some cases. MakerBot has released a new printer head. They're calling it like a MakerBot Lab setup, which basically means you can put any filament in it and it should work. Keep that in mind when you are looking at 3D printers, that if you want to expand and work with different materials, you're going to want a printer that has open filament, or that allows for open filament. All right, so we are laying down our first, that looks really good. So we're running at this looks like normal PLA printing speeds. We're at like 210 for...
220 for 10.
220 for the hot end and about 80 for the bed. It's going pretty well. YouTube can't see. Oh no.
Beautiful. Oh, you know. What are you doing?
Alright, so first layer is looking really good. So the laywood filament, the wood stuff, if you change the temperature, you could get like rings because the wood was actually being burnt, I guess. So I'm not sure if this will work on this one. We can give that a shot as we go up. We did glue the base, right? No?
That's just there in case it peeled up.
Okay. So if you are printing, there's, as many 3D printer users know, there's many ways you can get your bed to work, and that's, delaminating apart is one of the major failure modes of 3D printers. The way I like the most, I don't know, do you like the glue stick? Because that's my favorite.
If it doesn't stick to just Kapton, then adding the glue definitely is awesome.
Yep. So the Kapton's this tape here. Kapton tape is just a high temperature tape. They use it a lot in like TVs to hold down wires, computers. It's just a high temperature material and adhesive that makes it work in those high temperatures. Josh was just mentioning, if we didn't hear, that if it doesn't stick to the Kapton without any glue, you can use glue sticks, and we recommend an Elmer's glue, washable glue, school glue stick, all-purpose clear. Great stuff. There's other methods. There is build tack, which is a plate of, I don't know, type of plastic. Basically, it's a plastic that the print adheres to and, grabs pretty well. I think we have a few of those printers, right? Yours is?
That's the one that's magnetic and you can take it off and bend it.
Yep, that's their new one. There's blue painter's tape. There's all sorts of methods to do that. Would not recommend hairspray. People use that. That can get dangerous and it's pretty messy. Okay, so now we are through the first layer. We're doing our first layer around the brim. This is working pretty well. Yeah, I like it. Is that really a 0.75? Yeah. Nice. So I did have the I should have had the print. The aluminum print did jam, and the nozzle we think it filled up. Was that hard to get out, Josh, when you were cleaning it, or?
I had to change the nozzle out.
Okay, so the aluminum one did fill up the nozzle. I'm not sure if I had a 0.75 in it. I really don't do a lot of printing. I'm like running around and everybody else is doing the printing, and they're all fixing my problems with the printers. But I did have the aluminum jam, and that was probably because of the nozzle size. So larger nozzle, more flow through, and less clogging. So yeah, it's somewhere on my desk.
Why would that filament be more prone to clogging?
I think it's because the aluminum is the wood can kind of shrink and be compressed compared to the aluminum that can't be compressed. That's a wild guess.
A swag?
Yeah.
Statistical wild guess?
Yeah. What else do we have on this? We didn't have this in the previous video. How's that in the camera? What? Pretty good? So this is the pulverized plastic with the aluminum. And you can see it stays pretty well mixed in this bag. And that's the key when you're making additives or filament with the additives infused with our Filabot systems, to make sure it stays suspended. If we had pellets in here and the aluminum powder, all the powder would be kind of towards the bottom, which then wouldn't create a homogeneous mixture when you're extruding. That was almost a tongue twister. So now do we just like watch the print? I mean, it's kind of a long print. I think we should just let it run. All right, well, I'm gonna step out. We're gonna let this print run. We'll come in and change the temp size or temperature, like maybe halfway through, and we'll see if we can change the rings and create those like fake wood rings in this filament. Not sure if it'll work. It will be a long print, warn you. Probably a boring section of the video, and we may get rid of that in post-processing of this video. If you have any questions, please give us a call, send us an email, do whatever that social stuff is, and happy printing. Thank you. Now leave the YouTube going.
No, you just gotta stay on everything. For an hour and a half. You want to stand in front of it?
If we're gonna,
Tyler. That's what you look like the whole time.
hold on. I swear I didn't intentionally press anything. Do we want to send them over to YouTube since we're going to cut this one?
YouTube's still on. We're just gonna let YouTube go.
But do you want to hop on camera and tell them that? Since we're going to cut Facebook? Yes. And there's still people watching?
Dear Facebook watchers, go to, do I still have the glasses?
Still have the glasses.
Nice. Please go to our YouTube channel for the full stream of the print here. We are going to turn off the Facebook because Jeremy's arm is getting tired.
So tired.
So tired. But thank you for watching. Cool. we had a technical difficulty, really the nozzle jammed, and hence the reason you should have large diameter or large nozzle size. So we took the print off and we're going to try printing it again. We brought the temperature up to 230 degrees C, and we hope that that will, well, allow the plastic to go through. So we're going to start again and let you enjoy this beautiful print. Cheers.
Is anybody even watching?
I think I got two. Okay, so printer jammed again. We're going to clean the nozzle. That's going to be boring, so we're going to shut off the live stream. But thank you for watching, and until next time, cheers.